Good morning students. Today I am going to explain the signal conditioning circuit for RTD. So what is meant by RTD? RTD means resistant temperature detector. It is the temperature sensor used to measure the high temperature in the furnace. There are two types of RTD. One is PTC, another one is NTC. PTC means positive temperature coefficient. If the temperature increases at the same time, the output resistance increases. NTC means negative temperature coefficient. If the temperature increases, the output resistance decreases. Understand? Here, R1, R2, R3 is used as an ordinary resistor and R4 only we are using RTD. Here we are using PTC type PT100. PT means platinum, 100 means at 0 degree Celsius. The resistance value is 100 ohm. V1 is the source voltage for this bridge circuit. Okay. See, you have to assume that the RTD is in temperature bar. What will be happen? If the temperature increases from 0 to 100 degrees Celsius, the corresponding output resistance start increases from 100 ohm to 139 ohm. How it will increase? See the formula. Here we are using platinum 100 RTD. Okay. So the formula to find out the change in resistance from 0 to 100 degrees Celsius RT, which is equal to R naught into 1 plus alpha del T. R naught means at 0 degrees Celsius the resistance value is 100 ohms. Alpha means the damping coefficient value for the platinum, which is equal to 0.0039. Del T means change in temperature. So we have to measure the change in resistance for 100 degrees Celsius. Okay. So what is the value? 139 ohm. So you have to change the value from 100 ohm to 120 ohm manually. So the bridge will be unbalanced and the corresponding bridge output voltage will be indicated in the node VA and node VB. So how to calculate the node voltage? By applying the voltage divider rule. Okay. So what is the voltage divider rule? So opposite resistance divided by total resistance into V1, we are getting VA and this procedure is same for VB. Okay. So after find out the bridge output voltage, you have to design a signal conditioning circuit for this RTD. Here we are using instrumentation amplifier to boost up the voltage from millivolts or microvolts, that is sensor output, millivolts or microvolts into volts. Okay. How to design an instrumentation amplifier? So we have to design a signal conditioning circuit for 5 volts. What is the formula? V0, which is equal to 1 plus 2R by RG into the differential bridge output voltage Vin. Okay. So you have to assume all the resistor in the instrumentation amplifier as 1K except RG. So you have to find out the resistor value RG. RG means gain adjusting resistor. Okay. So you have to assume the resistor value R as 1K and you have to find out the RG value. What is your RG value? You are getting 5 ohm. So you have to apply the resistor value RG 5 ohm in the given circuit and you have to save and simulate the program. Okay. You go to simulate, then click edit simulation command. So you have to put 1 second. 1 second means the total time period for x-axis is 1 second and the time to start saving data 0 means the graph starts from 0 seconds. Maximum step time means start increases from 0.1 seconds. Understand? Then you have to run the program and you have to change the window from horizontally to vertically. Then finally you have to touch your probe in the node VA. What is the theoretical node VA voltage? 250. Practically you are getting the same voltage. See the table. Then you have to touch the probe in node VB. So what is your theoretical VB? 260. So practically you are getting the same voltage. Understand? So finally you have to touch your probe in the output side. So what is your design voltage? For 5 volts you have to design. So practically you are getting 4.356. Understand? Thank you.